Okay, this is just another example of performing row operations on a graphing calculator to solve a system with Gauss-Jordan elimination. So I'm going to just pick up from where my last video left off by going into my second matrix menu and editing the matrix that I was working with because I don't need it anymore. And this time I need 3 rows and 1, 2, 3 columns. So I need to have a 3 by 3, and then I'm going to enter in the values of 2, -1, -4, 2, 4, 6, 3, -1, and -1. Okay, so I've got my matrix entered, and now I'm going to follow. I know these are predetermined steps and you're going to have to come up with these on your own, but we can go ahead and talk through them. So what I decided I wanted to do in this case was switch row 1 and row 2 to get started. And the reason I wanted to do that was because this row right here can be multiplied nicely through by a half to create a leading 1. Whereas this one can't be, and neither can this. So I'd like to first just move this one up, and then I can continue from there. So I'm going to go ahead and quit out of here now, and then go back into my second matrix. Notice it's now a 3 by 3, so it's saved under there. Now I want to perform a row swap in this case. So we haven't seen one like this before. So what you might want to do is go back up here to row swap. You say what matrix you want to do this to, and then you just enter the 2 rows that you would like to switch. So I'm working in matrix A. Again, you could have other matrices listed here, so that's why it's important, why you always have to do that. And I want to swap rows 1 and 2. It doesn't matter really the ordering in that one, since they're just getting switched. But I do want to store it back into a new matrix A. Okay, so all that did in my calculator was reverse those 2 rows. Could you just do that one by hand? Of course you could, but I wanted to show you how to do it on your calculator as well. Now I can easily take this first row and do a times row by a half or 0.5 in order to create the leading 1 that I want. So I want to multiply that in matrix A. And what row am I doing that to? I'm doing that to row 1. Store new matrix. Okay, so that created my leading 1 here. Now my next step is to turn these 2 entries into zeros. So I need to use a -2 to get rid of this one and a -3 to get rid of this one. And in both cases, we're using this 1 in order to do it. So I'm going to go back into my second matrix, math, choose times row plus. First one is a -2. And we're using 1 to change row 2. And I know I'm doing this fairly quickly, so feel free to pause as you do those steps, but that changes row 2. Now I also want to change row 3 while I'm here. Oops. And I messed up, so I want to do second matrix, go over to math. Okay, that brings up my option here to multiply by a -3 in matrix A, using row 1 to change row 3 this time. So it's really important that you write those row operations out, not only for me, but for yourself, so that you have those directions to follow as you're doing this in your calculator. Okay, so now my next job is to turn this entry right here into a 1. So I could do that by multiplying by -1/5 or by -0.2. And it's going to come out nice enough there if I do that. So second matrix, to my math option, times row. I want to multiply by a negative 0.2 though, make sure it's negative, in matrix A, and I'm doing this to row 2. Okay, I created my leading one right here. And so my next step is to turn the above and below entries into zeros. I need a -2 to do this one and a +7 for this one. In both cases using row 2 in order to change rows 1 and 3. So go to my second matrix math, choose times row plus. I want to multiply by a -2. Matrix A. I'm doing this to row 2 to change row 1. Store. Okay, that fixed my top row here. Now I need to fix this bottom row. Second matrix math times row plus. This time I'm going to multiply by a +7. Matrix A. And I'm using row 2 to change row 3 this time. Store back into matrix A. Okay, so I have this now in that row reduced form. I have leading ones with zeros above or below them. Right now I have that x is -1 and that y is 2, but I have this statement down here that apparently 0 plus 0 equals 4. So that should be a red flag to us. Although everything appears in these that it's okay, this leads this to be a no solution situation. And I'm writing with my finger on my trackpad on my laptop, so I'm very sorry that this looks so bad. But this is definitely a no solution problem. And I could have sort of saw that coming. I knew it was going to be, or I could have known from the very beginning that it was either going to be no solution or an infinitely many, because I have, actually no, this one is the same dimensions, so it could have been any of the 3. So I really had no idea what was going to happen. I had to work it all the way out to the end to figure it out. And it happened to be a special one.